Hi everyone, today we will see the paper Cambridge IGCSE Physics Paper 3 October-November 2021. So first question is, a student uses a ruler to measure the length of a piece of wire as shown in figure 1.1. So this is the wire length, we need to measure this length. The ruler is here. Use the ruler in figure 1.1 to determine the length of the piece of wire. So the total length from this point to this point, it is around 14 point. Here it is 5, 6, 7, 8. That is 14.8 centimeter. And the wire starts from here. And from this 0 to this point, that is 1.56. This is 1.6 centimeter. So for finding the length of this wire, we can subtract, that is up to here it is 14.8 and up to this length it is 1.6. So 14.8 minus 1.6 will give the length of the wire, that is 13.2 centimeter. Next, the student fold the piece of wire and measure its mass. State the name of an instrument the student can use to measure mass. So for measuring mass, we can use a beam balance. The student determines the volume of the wire. He uses a measuring cylinder, part filled with water, and places the wire in it. So here we can see measuring cylinder is there, partly filled with water. In that he is putting the wire. Determine the volume of the wire. We need to determine the volume of the wire. So without inserting this wire, we will find what is the reading here. Here it is 10 and the middle point it will be 15, 16, 17, 18. So this point it will be 18 centimeter cube. After putting the wire, what is the reading here? Here it was 20, 21 and this will be 22. So if you are subtracting, that is 22 minus 18 will give the answer. Will give the volume of wire, that is 4 centimeter cube. Next, the student measure the mass and the volume of the piece of metal. The mass of piece of metal is 93.6 gram and its volume is 12 centimeter cube. So we need to find the density of the metal. So density of the metal can be written as mass divided by volume. So here mass is 93.6 gram, that divided by volume is 12 centimeter cube. Just will calculate it. That is 93.6 by 12, that is 7.8. So here the answer is 7.8 gram per centimeter cube. Question number 2. A slope is made by resting one end of the plank of wood on a block as shown in figure 2.1. Here we can see a block of wood, a plank is there, a trolley is there. Two students each uses a digital stopwatch to measure the time for a small trolley to roll down the full length of the slope. Figure 2.2 shows the times on the stopwatches. So student 1, we can see here minute second, that is here it is 6.14 seconds. Student 1 reads 6.14 seconds and here it is 6.28 seconds. 6.28 seconds. So on the line next to each stopwatch, write the time it shows. Already we have written that. Calculate the average time for the trolley to roll down the slope. So for finding the average time, we can add these two times, then divide by 2. That is 6.14 plus 6.28 by 2 will give the average time. If you are adding, you will be getting 12.42 by 2, that will be equal to 6.21 seconds. The student wants the same trolley to take more time to roll down the plank. Suggest how the students alter the arrangement. So they need take more time. So they can decrease the slope. If slope is more means, here if you are increasing the slope, the trolley will move so much faster. And if you are decreasing the slope, if you are reducing this height, or we can decrease this slope and we can decrease the speed. So we can decrease the angle of slope. So decreasing the angle of slope will have to take more time to roll down the plank. Next, a different trolley travels 1.2 meter down the slope in a time of 7.8 seconds. Calculate the average speed of the trolley. So speed can be written as distance by time. Distance divided by time. Here the distance is given as 1.2 meter and the time is 7.8 seconds. So we will do the calculation. 1.2 by 7.8. So it is 0.15. So the answer is 0.15 meter per second. Next, a trolley travels down a different slope and shows the speed time graph. Here the speed time graph is given. Calculate the distance traveled by the trolley between time t equal to 0 to time 4 seconds. That means from this point to this point, what is the distance? So this is the area under this graph will give the distance traveled. So here area under the graph means that is, it is a triangle, that is half into b into h, that is half into, here the breadth is 4 and height is, here it is 1.6. So this is 2 into 1.6 is 3.2 meter, that is the distance. So the answer is 3.2. Next, a student determines the center of mass of a piece of card. Figure 3.1 shows the equipment. So he is finding the center of mass by using this equipment. One roller is there. Describe how the student determines the center of mass of the card using the equipment. So 3 points it has been marked. So here now the point A is there. One pin on cotton thread is there. So for initially he can draw the line and he can change the points to C, B, then again he will be getting 3 lines. So This intersection point will be the center of mass. So same way, first A is here, we can keep B in same position, C in same position, and this thread, this line, he can draw it, and the intersection position will be the center of mass. So the answer is line drawn alongside So first we will be drawing the line in this way, in this thread position. Then we can hang the triangle from different corners. A, B, C is there. So first we will try A, then we will try B, then we will try C. Like that, 3 different corners needs to be hanged separately. And we will mark the points. Repeat marking of the thread. Thread position on the card. And the center of mass will be the line of intersection. Next, another card is pivoted at a point P. The weight of the card is 1.4 Newton and acts through a point 20 centimeter from P. So calculate the moment of weight of the card about the point P. So moment already we know, that is weight or force into the perpendicular distance from that point, from the pivot. Here the weight is given as 1.4 Newton and the distance is given as 20 centimeters. So the answer will be 1.4 into 20, that is 28 Newton centimeter. A substance cools from 50 degree to 5 degrees Celsius and its melting point is 20 degrees Celsius. The substance takes 30 minutes to cool from 50 degrees Celsius to its melting point. The substance takes a total time of 80 minutes to cool from 50 to 5 degrees Celsius. The graph is given here. So a substance, its melting point is 20 degrees Celsius. Initially the temperature is 50. This is 40, this is 60, and the middle of that it will be 50. So initially the temperature was 50, then it has been reduced to 5. Here 5 means this is 0, this middle point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here the middle point is 1, 2, 3, 4, 5. So this is the middle point, that will be 10, and 1, 2, 3, that 2.5, this will be 5. So from 50 degrees Celsius to 5 degrees Celsius it is getting reduced. So this is 5 and this is the melting point 20. So in first 30 minutes, so starting when the time is 0, the temperature was 50. When the time was 30, the temperature is its melting point, that is 20. So what we need to find here, on figure 4.1, sketch a graph that shows how the temperature of the substance varies with time as it cools from 50 to 5. So it is cooling, so the temperature is getting reduced. We need to plot the graph. So for first 30 minutes it will reach 20. So first point is here, that is 50. When the time is 30 it will reach 20. So first line we will draw here. Next it is reaching 5 degree after 20 when the time is 80. 80 means this corner point, that is when it is 80. This is actually 80. So when it is reaching 80, the temperature is 5. So approximately here it will come. So this is the point. So we can plot the graph like this. When it is 0 it is 50, when after 30 minutes it was 20, when it is 80 it was 5 degrees Celsius. Next, describe the arrangement and motion of the molecules in a substance when they are in the solid state. So we know, so in solid state molecules are so much closer than liquids, and they are in a regular arrangement and in fixed position, and they can only vibrate. They will be having a crystallized pattern. Comparing to liquids and gas, these molecules will be having a closely packed arrangement. They are closer than liquids and gases. They are in a regular arrangement. And they will be in a fixed position. So they can only vibrate. Next, figure 5.1 shows a plastic bottle on a bench. The plastic bottle contains liquid. So some liquid is there inside. The weight of the bottle and the liquid is 12 Newton, and the area of the bottle in contact with the bench is 25 centimeter square. So what is the pressure? So pressure equation is force divided by area. Here the force is given as 12 Newton and the area is given as 25 centimeter cube. So 12 by 25, that is 0.5 48 Newton centimeter square. A student pours out all the liquid from the bottle. Then she connects the bottle to vacuum pump, which removes all the air from the bottle. Figure 5.2 shows the bottle after most of the air is removed. Explain why the bottle is crushed. We can see the bottle is being crushed. Use your idea about molecules. So here, when the air is removed from the bottle using vacuum pump, the number of air molecules inside the bottle has been reduced. So by using a vacuum pump, air is being removed. Because of that, the number of air molecules inside the bottle decreases. So as the molecules are less, this creates a lower pressure inside the bottle. So air molecules inside the bottle is less here. So the pressure inside the bottle will be less. A lower pressure will be created inside the bottle. So outside the pressure will be more comparing to the inside pressure. Higher pressure in the surrounding atmosphere. So in the absence of enough air molecules inside the bottle to counteract the external pressure, the higher atmospheric pressure outside exerts a force on the walls of the bottle. So two forces are there. From inside one pressure is there, from outside one pressure is there. But inside air molecules are very less comparing to outside. Inside pressure is less, outside pressure is more. Here the force has become unbalanced. Force is unbalanced due to the lower pressure inside, causing the walls of the bottle to collapse or crushed inwards. Because of this unbalanced force, due to this unbalanced pressure created, the bottle is being crushed. Next, figure 6.1 shows a part of water wave. Here we can see one wave. Amplitude is being marked, the height is being marked as P. The wavelength here it is being marked from one node to another, that is R. Peak to peak value is being marked. So state the letter P, Q, R, S or T on figure 6.1 represents the wavelength of the water. Here the wavelength means that is from this node to this node, what is the length, that is the wavelength, that is R. State the letter P, Q, R, S or T on figure 6.1 that represents the amplitude of water wave. So amplitude means this height, that is P. State what is meant by the term frequency of the wave. So frequency of the wave refers to the number of complete cycles or oscillations. That is the number of complete cycle or oscillations that occur in a given unit time. It means in a particular time how many cycles has been completed. That is the frequency. Next, two students A and B uses echoes to measure the speed of sound. Student A has two blocks. So this student A, he is having two blocks that would make loud sound when back together. Student B, she is having a stopwatch. They stand 120 meter from the school wall. Describe how the student uses the arrangement in figure 6.2 to determine the speed of sound in air. So, for finding the speed, first he need to make sound. That is, student A, he need to bang the two blocks. Student A will bang two blocks. So, sound is being produced. Same time, when he is producing the sound, student B need to on this stopwatch. On stopwatch. So he will produce the sound, same time she will on the stopwatch. So after some time, B should stop off the stopwatch when she is hearing the sound. So when this B will hear the echo, when she is hearing the echo, she need to off the stopwatch. And from this calculation, they can find the distance. So here, as they are hearing the echo, the total distance it is 120 meter, and echo means again it is we need to add 120 meter. It is traveling up to this point, up to this school wall. Again it is traveling back to them. So it will be, the total distance will be 240. So D can be taken as 240. As it is echo, the D will be 2 times the normal. And they can find the speed by using the equation distance divided by time. Speed is equal to distance divided by time. Here it is 2 times the distance by time, as they are hearing echo. Next, figure 7.1 shows a ray of red light entering a semicircular glass block. The ray strikes the flat surface of the block at X and emerges into the air. Figure 7.1 does not show the path of the refracted ray in the air. So here on figure 7.1, draw the path of the refracted ray in the air. First we need to draw the path of refracted ray. So this is the incident ray and it is refracted outside. This will be the angle of refraction, and with respect to normal, this will be the angle of incidence. So here next is mark and label with letter I the angle of incidence. So this is your angle of incidence, the angle incident with respect to the line with respect to normal. Next is mark and label with letter R the angle of refraction with respect to normal, the refracted line, that is the R. When the angle of incidence at x is 70 degree, the ray does not emerge from the glass into the air. State what happens to the ray at x. Explain why this happens. If the ray is not emerging from the glass into air, their total internal reflection has happened. This occurs as the angle of incidence is greater than critical angle. That means it is incident around 70 degree. It will be refracted inside. It is not going outside. That means total internal reflection has happened. And this total internal reflection occurs when the angle of incidence is greater than critical angle. This happens when the ray is traveling from a denser medium strikes the boundary with less dense medium. The ray is traveling from a denser medium to less denser medium. At times the angle of incidence will be greater than critical angle, and this total internal reflection will occur. Here we can see it is glass, it is more denser medium comparing to air. So when this ray is traveling from this glass to air and the angle of incidence is more than the critical angle. Critical angle actually depends on the refractive index of the medium N1, N2. So as the refractive index varies, the critical angle also varies. Next, the visible light is one part of electromagnetic spectrum. X-rays are also the part of electromagnetic spectrum. So, visible light and X-rays are traveling through vacuum. Compare the speed and frequency by completing the sentence. So, here we can see the electromagnetic spectrum. So, visible light. Here we can see the visible light. This is X-ray. The frequency also we can see here. The visible light is having lesser frequency compared to X-ray. X-ray is having more frequency. It is like this, it is going, the frequency is more. So our question is, the speed of visible light is same as the speed of X-rays. Speed will be same because all waves in this electromagnetic spectrum will be having the same speed. And the frequency is varying. The frequency of visible light is smaller than the frequency of X-rays. Visible light will be having smaller frequency than X-rays. Next, describe one use of X-ray. It can be used for the treatment of cancer. Next, figure 8.1 shows a magnetic field pattern around a bar magnet. On the figure, label the north and south poles of the magnet. Use letters N and S. So here arrows has been shown, right? Always the arrows will be pointing from north towards south. So we can see from north pole to south pole only these arrows will be pointing. So this side it will be north and this side it will be south. From north it will be outwards, and in south it will be inwards. The arrow will be pointing inwards. A soft iron bar is positioned as shown in figure 8.2. Here we can see one soft iron bar. State and explain what happens to this bar. So here it was north pole, here it was south pole. So when this soft iron bar is kept near this, it will this attracted towards this north pole, and it will be acting like an induced magnet. It will act like a magnet with opposite pole. Here it is north, means here it will be south. So here this soft iron bar is attracted towards the north pole of the magnet. And it becomes an induced magnet with opposite pole nearest to the magnet. Next, a plastic rod is rubbed with a cloth. The plastic rod becomes positively charged. Explain how the friction between the cloth and the rod causes the rod to become positively charged. So there is a plastic rod and it is being rubbed with a cloth material, and the rod has become positive charge. Use your ideas about the movement of charge. So as it has become positive charge means electrons from this rod has moved towards this cloth. The cloth will be negative charge. Electrons from rod move towards the cloth. So here electrons move from the rod to cloth. Next, plastic is an electrical insulator. Iron is an electrical conductor. State two other materials that are electrical conductors. Copper is a good conductor. Aluminum is also a good conductor. Next, this question is about electric circuits. State the name of the instrument used to measure potential difference in an electrical circuit. Potential difference can be measured with the help of voltmeter. It is actually potential difference, or we can tell it as voltage. It can be measured with voltmeter. State the unit for the electromotive force of a battery. That is voltage. In the unit is volt. A student connects a circuit to determine the resistance of a wire. The current in the wire is 0.2 amps and the potential difference is 6.4 volt. So current is given, potential difference V is also given. Current is 0.2 amps and potential difference is 6.4 volt. Calculate the resistance of the wire. As per Ohm's law, V is equal to IR. Voltage is equal to current into resistance. So resistance can be written as V by I. Here voltage is given as 6.4 volt and current is given as 0.2 amps. So 6.4 by 0.2, that is 2, that is 32 ohms. The student has some wires of the same material as those in question B1 but of various length and thickness. So length is different, thickness is also different. He wants a wire with higher resistance than the wire in B1. State two ways of identifying a wire with higher resistance by comparing its length and thickness. So resistance can be written as R is equal to rho L by A. Here L means length. As the length increases, resistance also increases. And A is area. Area means it is related to its thickness, or we can tell it as diameter. As diameter increases, thickness increases and its area increases. So here, if these factors are decreasing, area, that means thickness or diameter is decreasing, means resistance will increase. So higher resistance, if we want a higher resistance wire, we need to increase the length and decrease the diameter or thickness or area. So one point is length can be increased. Another point is diameter can be decreased. Next, a student plans to demonstrate the induction of an electromotive force in a wire. He has a length of wire, a sensitive reading galvanometer and a permanent magnet. Describe how the student uses the equipment. So, one galvanometer is there and a wire is there. So we can connect the wire across the galvanometer, and one permanent magnet is there. So if you are moving the magnet near this wire, this is your wire. So if you are moving the magnet near the wire, according to Faraday's law of electromagnetic induction, an EMF will be induced. Here the principle is Faraday's law of electromagnetic induction. So how we can use, one point is connect both ends of the wire to galvanometer. Next is move the magnet relative to wire. Next, state two ways in which the student can increase the size of the induced EMF. How we can increase the induced EMF? So if you are increasing the strength of magnetic field, if the magnetic field strength is more, means the induced EMF will be more. Or we are turning this wire, there are more number of turns, or we are turning the wire and using, the induced EMF will be more. And if you are frequently, the rate of speed or the increase the speed of the magnet, we can increase the induced EMF. So 2 points I will write here, that is by increasing the strength of magnetic field, we can increase the induced EMF. Next is turn the wire into a coil or increase the speed. Increase the speed of motion of the magnet relative to wire. Next, figure 10.1 shows a DC motor. We can see a DC motor here. Draw an arrow between the poles of the magnet to show the direction of magnetic field. So here north pole is there, south pole is there. Always the magnetic field will be from north to south. State two ways of making a coil spin faster. So here a battery is being connected. So if we increase the battery voltage, we can increase it. Then the number of turns in the coil. Here one coil is connected. So number of turns. If we are increasing the N, we can increase the speed of spinning. So one is increase. And by increasing the strength of magnetic field also we can increase the spin. Increase the battery voltage or increase the number of turns or increase the strength of magnetic field. State one way of making the coil spin in the opposite direction. Suppose we want to spin it in the opposite direction, we need to change the polarity of the battery. If the polarity, that is here you are giving positive, here you are giving negative. If the polarity is being changed, we can change the direction. That is reverse the polarity. Reverse the polarity of battery. Next, alpha particles, beta particles, gamma particles. Gamma rays have different characteristics. Complete the table. So we need to complete the table. Alpha particle will be having large mass, then most ionizing in that it is alpha particle. Most penetrating means that is gamma. Negatively charged, that is beta. Greatest speed, that is for gamma rays. A sample of radioactive materials contain 80 mg of sodium. That is the initial amount, N0, sodium 24. The half-life is 15 hours. So the half-life, capital T, it is 15 hours. Calculate the mass of the sodium after 45 hours. Small t is 45 hours. So the final mass we need to find, that is Nt, that is the final mass. That will be equal to N0 initial mass by 2 raised to T by T. So initial mass it is 80 by 2 raised to small t is 45 by capital T, that is 15 hours. So here 45 by 15 means that is 3. So 80 by 2 raised to 3. 2 raised to 3 is 8. So 80 by 8. 80 by 8 means it is 10. So the answer is 10 mg. So thank you. We will see in the next video.